Now, dear students, lecture number 6, class second year, and chapter number same 13. I told you this is a very big chapter, and I started in the previous lecture group 1 elements. Group 1 elements: lithium, sodium, potassium, rubidium, and cesium or calcium. So we reach up to the electropositivity, electronegativity, and the melting point and boiling points. Melting point and boiling points. So I am going to start melting point and boiling points of alkali metals. So if you open your book, page number 25. Trends in melting and boiling points of group number 1 elements. If you see the graph, lithium unusual, very high melting point, boiling point, very high. Unusual melting point of the lithium is very high because lithium actually very hard. It can scratch the glass. It can expand the glass. It's a hard one due to the very small size. There is one thing I want to tell you. If you visit the periodic table, mostly, not 100%, mostly you will find that first element of every group, I'm talking about S block and P block elements, first element of the group does not resemble its behavior, its own group. It shows some dissimilarities. We call peculiar behavior. This is called a peculiar behavior, unusual properties. So alkali metals, lithium is the hydrogen. Hydrogen is not a matter, it is temporarily present in the periodic table, already I told you. Hydrogen has no permanent place in the periodic table still. So because of its electronic configuration is similar with the group number 1, that's why it is adjusted. Otherwise hydrogen is a gas, it is a non-metal, so it has no permanent place. Started from lithium. So lithium does not resemble its own group. Many properties different. Lithium's properties are many different. So that's why unusually lithium has a very high melting point because of very small in size. But as you go down the group from sodium to calcium, this is going to be decreased. The melting and boiling points are very low because of presence of weak intermolecular metallic bond in alkali metals except lithium. So that's why it decreases down the group. Lithium is very high. I told you the answer. Density. Density of the group number 1 elements. The alkali metals have a quite low density due to the large atomic volumes. So if you see lithium very low, there is an unusual. We say there is no rationalization. These are not rationalized. There is an unusual character. See, lithium low, then sodium high, potassium low, rubidium high, then cesium high. So there is a gap between the sodium and potassium. Lithium is going to decrease, then sodium is very high, then potassium decreases, then sodium is high, and cesium is very high. The density of increases with increasing atomic number, but there is a difference between potassium and sodium, I told you. Because of the size, atomic size, the more than compensate for the bigger size of atoms. And written here in the last two lines, potassium is however lighter than sodium. Potassium is lighter than sodium, which is due to the unusual increase in atomic size of the potassium. Unusual increase in atomic size of the potassium, that is why its density is going to be decreased and sodium as higher. For this reason, please remember this one. This is the 19.20 graph. Then there are the quick quizzes. Why potassium is lighter than sodium? Again, I told you from this paragraph, you write the answer. Explain the second ionization energy. Yes. I am talking about group number 1 elements. When we are talking about group number 1 elements, then their electronic configuration is an ns1. In the S last shell, there is a 1 electron. So it can be lose 1. So that's why its first ionization energy is very small. It can be lost very easily. This electron can be lost very easily. That's why the first ionization energy of these elements is very low. Second ionization energy means when you are going to move another electron, so very difficult. But it's quite impossible, because if I am going to write the electronic configuration of sodium atomic number 11, 1s2, 2s2, 2p6 and 3s1. This is. So first ionization, you can lose this electron from the sodium outermost shell, so it can give a positive 1 charge. But students, when it is going to be remove 1 electron, because K shell is complete here and L shell is complete, and P has 6 and S has 2, so 2 electrons and 6 electrons, they are going to finish. Duplet pool and octet pool both are, and L shell is completed. So tremendous amount of energy is required to remove the electron from the 6, but it's impossible. Group number 1 and group number 2 elements always they show a positive 1 and positive 2 oxidation number respectively. Because group number 1 always lose 1 electron and group number 2 always lose 2 electrons. There is no possibility for the losing second electron, second ionization. So it is very, very high. Indeed, this is the answer for the question number 2. The melting point, alkali metals are very low because of due to the large atomic volumes. This is given in the explanation. Please do this one. So students, there is a trend in reactivity with water. Already I think we done this topic, many repetition is there. Trends in reactivity with water. We done this in the previous topics also. Same. I told you that alkali metals are very reactive. If you compare with the whole periodic table, most reactive groups in the periodic table, and this reactivity increases as we go down the group. This reactivity is going to increase. Lithium, if I put on the sodium, very low, very slow chemical reaction. Sodium, very fast. Potassium, rubidium, cesium, they are fastest. Even minus 100 degrees centigrade, potassium and rubidium, they can react with. So reactivity is a very, very high and very high exothermic reaction taking place. So this is the reaction with water. I told you very vigorous, very explosive and exothermic. A reaction with oxygen. Reaction with oxygen. Dear students, lithium, if you open the page number 26, you should have your book. Reaction with oxygen. Lithium reacts with oxygen to form a normal oxide. When I say normal oxide, this is the lithium and this is oxygen to give a lithium oxide. This is called a normal . This is the normal oxide. When we say normal oxide, the oxidation number of oxygen is -2. In the normal oxides, the oxidation number of the oxygen is a -2. Sodium form peroxide. Sodium form peroxide. In the peroxide, oxidation number of oxygen is going to be -1. Other potassium, rubidium, by this one, they form superoxides. They form this is the normal oxide, and this is the peroxide, and this is the superoxide. The oxidation number of the oxygen is -1, -half, -half in the superoxide. Normal oxide, peroxide, superoxide is due to the increasing reactivity of elements top to bottom. This is the reason. Now, another very good reason is that as you go down the group, the percentage of oxygen is going to be increased. In lithium oxide, ratio is 2:1. In sodium oxide, equal ratio 2:2 equal. In potassium superoxide, the ratio is inverse, that is a 1:2 oxygen. So, number of oxygen atoms is going to be increased as we go down the group due to the reactivity of the alkali metals. This is the sodium peroxide. Usually in the laboratory, sodium normal oxide is not going to be prepared. Sodium normal oxide cannot be prepared in the laboratory very easily. So indirect method is given in your book. Since the normal oxides of alkali metals other than lithium are not going to be formed, so that is why the method is indirect. So from the peroxide, if you have a sodium peroxide, by using sodium to give a sodium normal oxide, this is a sodium normal oxide. So this is the sodium normal oxide. I use peroxide, sodium, and this is normal oxide. And there is a sodium nitrite. Again sodium, and you will get again sodium normal oxide plus also nitrogen gas. This is also nitrogen gas. You will get this one. If you balance 6 So this is a sodium nitrite, sodium metal, normal oxide, nitrogen gas is going to be involved. So there is a mistake in the last equation. This is a sodium nitrate, not nitrite again. This is nitrate, make it NO3. This is a nitrite, and this is a nitrate, this is a nitrate, not a nitrite, so please you have to correct it. So you will get again normal oxide sodium and nitrogen gas. So from sodium peroxide, from sodium nitrite, from sodium nitrate, you are going to put the sodium metal. So normal oxide going to be formed indirect by using indirect method. This is the indirect method for the preparation of sodium oxide. Now properties. Normal oxide, I told you, a -2 charge. This is a normal oxide and it's going to be changed into hydroxide. Yes. Reversible reaction. This is what's written here in the book. Normal oxide react with water to form hydroxide by the proton exchange. Proton exchange. So here, bridge. In the oxide and hydroxide, there is a gain of proton. He said proton exchange. So here is a gain of proton and here is a loss of proton. Hydrogen ion is called a proton. Hydrogen ion is called proton. So in this case, there is a gain, addition of proton, and in this case, a loss of proton hydrogen. This is a reversible process, gain and loss of proton. You can see your book. Peroxide, oxygen, two oxygen have a -2 charge. Like this one. Two oxygen have negative. This is peroxide, -1 charge for the oxygen. So dear students, there is a peroxide, a strong oxidizing agent, and react with water to give a hydrogen peroxide. So this is a peroxide and going to react with water, and you are going to form a hydrogen peroxide and plus oxygen gas. He said that the peroxide and superoxides, actually here the formula is wrong. Superoxide, I told you, has a, it should be like this, but in your book written here like this one. No, in your book written like this one. So this is wrong. This is the correct, because superoxide has a -half oxidation number, -half. If I have a 2 oxygen, -1. Overall -1 for the 2, so this is a superoxide. This is the peroxide, and this is the normal oxide. This is normal oxide. It's a wrong book. It's a mistake in the book. Is corrected. Okay. So superoxides, peroxide, oxidizing agent. You done grade 11 oxidizing agents, substances which reduce themselves and oxidize other. Reduce themselves and oxidize other. So this is the oxygen, which is a peroxide, has a -1 oxidation number, and it is going to be changed into oxygen 0, So this is going to be oxidized itself. It is going to be oxidized itself. So this water, oxygen has a -2, in the peroxide there is a -1. So there is a decrease in oxidation, this reduction. So oxidation reduction goes side by side. Oxidation reduction goes side by side. So these are the reaction of oxidants. Now other topics. The new topic, page 27, is the reaction of oxides with water and dilute acids. Reaction of oxides with water and dilute acids. So this we done in the previous, that metallic oxides dissolved in water to give alkalis, bases. Sodium oxide dissolved in water to give us sodium hydroxide. Lithium oxide dissolved in water to give a lithium hydroxide, which is given in your book. And these oxides, this repetition top, I told you there are many repetition. And these oxides, when react with acid, to give us salt and water. If you see the previous lecture, we done this. These basic oxides, magnesium oxide, sodium oxide, lithium oxides, are the basic oxides. When they react with acid, dilute acid, hydrochloric acid, to give salt and water utilization. So, peroxides. This is a peroxide, sodium peroxide. When you are going to react with water, peroxide, if the reaction is done in ice, in cold ice, and the temperature controlled so that does not rise even though these reactions are strongly exothermic. So you have to react these peroxides in water in controlled condition. Even he said low temperature ice, but you have to be careful for this one. Highly exothermic reactions are in the solution of metal. You will get hydroxide and you will get and other peroxides. So hydrogen peroxide is going to be 4. Sodium peroxide dissolved in water, sodium hydroxide, hydrogen peroxide. Hydrogen peroxide will be formed. So if the temperature increases as it is, inevitably will, unless the peroxide is added to water very slowly, not with a very high stream, you have to put sodium hydroxide, sodium peroxide very slow stream. The hydrogen peroxide is going to be produced, and he said that it decomposes into water and oxygen. So this hydrogen peroxide may be decomposed into water and oxygen. So that is why the reaction can be very violent overall. Highly exothermic reaction is. So this you have to be very careful while doing these types of chemical reactions. Reaction with dilute acids, even very dangerous. Very dangerous chemical reaction, highly violent. So you will get the and hydrogen peroxide. Salt and hydrogen peroxide. So again he said that these reactions are even more exothermic than previous one, more than this. Highly violent, very violent. The solution containing salt and hydrogen peroxide is formed. The hydrogen peroxide again after formation decomposes to give water and oxygen gas. So that is why if the temperature rises again, it's almost impossible to avoid this. Don't do this chemical reaction. If the temperature rises, it means that a very dangerous chemical reaction and you have to avoid. Don't do this chemical reaction in normal conditions in the laboratory in front of students. Don't do this. Superoxides. Superoxides. So this is the potassium superoxide. Reaction with water to give potassium hydroxide, water, and also oxygen gas. So this reaction is different from the previous one. It is different from previous one. Three products you have here. Potassium hydroxide, water with oxygen also is going to be formed. So when superoxides react with water, the solution of metal hydroxide, hydrogen peroxide, and oxygen also form. But oxygen is going also, yes. Once again, these reactions are strongly exothermic, and the heat produced with the inevitably decomposed hydrogen peroxide, again water and oxygen, again the chemical reactions are very, very exothermic. So these superoxides, when react with acid, these reactions don't do in normal conditions. No. Don't do in normal condition because these are highly exothermic reactions. So when these oxides are containing salt and hydrogen peroxide with oxygen, the hydrogen peroxide will again decompose to give water and oxygen. So this is same as we done. So that this decomposes to give water and oxygen gas. Water and oxygen gas is going to be yes. So this is done in the previous also reactions that when hydrogen peroxide is going to form, so it forms a hydrogen peroxide will decompose in all chemical reactions to form water and oxygen gas. Now simple reactions. Sodium and chlorine to give sodium chloride. Alkali metal react with hydrogen to give salt, lithium chloride, sodium chloride. So molten sodium burns the bright yellow film. Already I told you. This is identification of a sodium metal. Potassium, rubidium, cesium, violently chemical reaction with halogens. I told you that first element of the mostly every group shows a different behavior. So dear students, when you are going to heat lithium nitrate, this triangle will heat. Lithium nitrate and so lithium sodium same group, lithium and sodium. But when we decompose, the reaction is different. In the case of lithium nitrate, please note it, you will get a lithium oxide. Lithium oxide is formed nitrogen dioxide is going to be formed with the evolution of oxygen gas. This is a reaction of lithium nitrate when you decompose. But if you decompose sodium nitrate, so you will get sodium nitrite with oxygen gas. Sodium nitrite is the oxygen gas. So two different reactions. So lithium shows different behavior with the own group. But I am telling you, which is not mentioned in the book. Actually, the first element of the group resemblance with the second element of the other group. Lithium is the first metal of the group number 1 and it shows its resemblance with the second element of the group number 2, magnesium. So if I am going to heat magnesium nitrate, it gives magnesium oxide, nitrogen dioxide and oxygen gas. So first element of the group 1 shows its property with the second element of the second group. That is why lithium shows resemblance with magnesium. You can find in the different books. This shows, this is called diagonal relationship. We call diagonal relationship. And this lithium nitrate does not resemble with the sodium nitrate. See different chemical reactions. Also see the graph. The melting point of boiling point is very, very high and other elements low. Other many differences are there with the lithium and other elements of its own group. But many resemblance with the group number 2, with the magnesium. So dear students, we end this and you have to do the quick quizzes and concerned questions with the exercises. This is my assignment. Always I am giving you assignment here that you have to do the questions from exercises and quick quizzes and take out a print of different papers, question papers from the Federal Board website and do them slowly and gradually. Thank you very much. We stop here.